Hi, this is a ball. It's sitting there, doing nothing, being lazy. Whoa, why did it do that? Magic? Ghosts? Nope. Physics. To understand why anything moves at all, we have to talk about force. Force is just a push or pull on something in a certain direction. You push a door open? That's a force. A magnet pulls a paperclip. That's a force. Your boss pulls you back into the office on a Saturday. Okay, that's a different kind of force, but you get the idea. Newton, our favorite gravity guy, gave us a simple recipe for this. Force equals mass times acceleration. Now, what do all these words even mean? Basically, if you want to make something move, acceleration, you need a push, force. But how much push you need depends on how much stuff is in the object, mass. Want to move a pebble? A tiny flick will do. Want to move a literal mountain? You're going to need a lot more than a flick. But here is the weird part. If forces are everywhere, pushing and pulling on us constantly, why isn't the whole world just one giant chaotic collision? Because forces love to play tug-of-war. Look at a chair sitting on the floor. Gravity is pulling it down toward the center of the earth. It wants that chair to fall. But the floor is pushing back up, hard. In engineering, we call this the normal force. It's a perfect tie. The pull down equals the push up. When the forces are balanced like this, we call it equilibrium. And it is the reason your house stays standing instead of sinking into the dirt like a stone in water. If we want to put that on paper, balanced forces. Equilibrium occurs when all forces on an object cancel each other out, resulting in zero net force. Now, you might think zero force equals zero movement, right? Well, not exactly. The sum of the forces equals zero just means the object keeps doing exactly what it was already doing. If it was sitting still, it stays still. But if it was already zooming through space at 10,000 miles per hour and the forces are balanced, it stays zooming at 10,000 miles per hour forever. In engineering, zero force doesn't mean no motion. It means no change, no speeding up, no slowing down, and no turning. But life gets exciting when forces are unbalanced. When you kick that ball with your foot provides a force that is way stronger than the air resisting it. The tie is broken, the tug-of-war is won, and the ball goes flying. So every time you see a rocket take off, a car stop at a red light, or even a leaf falling from a tree, you're just watching a cosmic game of tug-of-war where someone finally started winning. So if you know all the forces acting on a basketball mid-air, you can predict with 100% certainty if the ball will go in the hoop or your neighbor's windshield. Whoa, did an apple just fall on my head? Yes, Newton, it did. That must have happened for a reason, said Newton. He realized that the same force pulling the apple to the grass is the same force keeping the moon from drifting away into the dark abyss of space. He discovered that every mass in the universe pulls on every other mass. Yes, even you. No matter how many gym days you've missed, you attract the whole universe toward you, at least a little. Hey, Newton, can you put that on paper? Yep, said Newton, and he gave us the law of universal gravitation. It's a simple rule. Bigger mass, bigger pull. Bigger distance, smaller pull. But here's the engineering catch. It's not just a little smaller. As the distance increases, the force gets smaller by the square. If you double the distance, the pull isn't half as strong, it's 4 times weaker. This is the inverse square law, and it's why astronauts feel weightless even though they're not that far from Earth. Speaking of astronauts, let's clear something up. People always confuse mass and weight. Mass is the blob. It tells you how much stuff is inside you. Weight is the force of gravity pulling on that blob. If you travel to the moon, your mass stays exactly the same. You didn't lose any atoms on the way. But your weight, it drops by about 83% because the moon is a smaller tug-of-war partner. So remember, you're not overweight, you're just on the wrong planet. Gravity is also the ultimate engineer of our solar system. The sun is so massive that its gravity is constantly pulling the Earth inward, but the Earth is moving sideways so fast that it constantly misses hitting the sun. It's basically falling forever in a circle. We call this a centripetal force. In engineering, we use these same rules to keep satellites in orbit so you can use your GPS to find the nearest pizza place. From falling apples to orbiting planets, it's all just one giant invisible game of pull. See? Simple. To cover the cost of this knowledge, one subscribe and one like will be sufficient. Tips may be left in the comments.